In this video, we are going to discuss about complex power. Okay. So, the complex power is important in power analysis because it contains all information pertaining to the power absorbed by the given load. Okay. So, here usually it is given the complex power is defined as it is usually measured in terms of volt ampere. Unit is volt ampere. It is a product of the RMS voltage, phasor, and complex conjugate of RMS current, phasor. So since we have used a complex quantity, so it has a real part and the imaginary part. Okay. So the real part is nothing but a real power, and reactive part is a reactive power. So I can write this complex power. Okay. Complex power is equal to VRMS into IRMS. Okay. So this I can also write it as IRMS square into Z. Okay. So this I can also write it as IRMS square into R plus Jx. Okay. Since the impedance I can write it as R plus Jx. So this I can write it as RMS square into R plus J into RMS square X. Okay. So this VRMS is nothing but Vm divided by root 2 into del V, right? And this one is Im divided by root 2 into minus del I, right? So I can write this one is equal to VRMS IRMS into del V minus del I. Okay. So this complex power VRMS IRMS into cos del V minus del I plus J into VRMS IRMS sin del V minus del I. Okay, so this term is called as real power, and this term is called as reactive power. This is also called as average power. So we have represented as a capital P, and this one is a new term, that is reactive power is Q. So I can write it as P plus JQ. Okay. So what is the average power means? This is only the actual power, right? This is the actual power, right? or average power that is delivered to the load. Okay, so what is Q? What is Q? That is reactive power, means it will not deliver or dissipate power. Okay, instead it will exchange. Okay, instead it will exchange power from the source to load, source to so it will exchange the power back and forth. Okay, back and forth of the rest of the network. Okay, so it is nothing but it is lossless. That is, it will exchange the energy between the load and the source. Okay. So if which means if Q is equal to 0 means the power factor value is equal to 1, right? Power factor value is 1. It is fully resistive, right? Purely resistive. If Q is less than 0, so if Q is less than 0 means the power factor is leading, right? So power factor is leading means it is a capacitive. Okay. And if the Q is greater than 0 means power factor is lagging. So it is an inductive load. Okay. So now I can write, so I can draw this, so I can write this complex power is equal to P plus JQ, where P value is equal to IRMS square into R, right? And Q value is equal to IRMS square into X. So this is nothing but the real part of the complex power, and this is nothing but the imaginary part of the complex power. Okay. So this I can write it as so if I take the magnitude of this one, the magnitude of the complex power, I will get root of P square plus Q square. Okay. So let me term this complex power as capital S. So if it is capital S means it is P square plus Q square. So I can draw the diagram like this. Okay. You can see if this is theta and this one is P and this one is Q. So the answer is yes. Okay, so I can write S is equal to root of P square plus Q square. Okay, so and this one is nothing but lagging. Okay, so if it is leading means the Q will be at the bottom. Okay. So this is a real term, and this one is a imaginary object. So this if this is the case, okay, Q, this is nothing but leading. This yes. So this triangle is called as power triangle. So you can see I have all the terms, right? I have all the terms, right? Complex power, and this one is nothing but apparent power. Q is nothing but imaginary term of the complex power, that is reactive power, and this is nothing but a real power. Okay, I have covered all the terms. So consider they have given one problem, and that is voltage across the load. Okay, across the load, so it is equal to 60 cos omega t minus 10 degree. Okay, and current through the element I of t is equal to 1.5 cos omega t plus 50 degree. Okay, so they are asked to find the complex power and apparent power. Then real power, and reactive power, then power factor and load impedance. Okay, so I can find the value of power factor, right? What is power factor? Power factor is equal to cos of del V minus del I, right? So what is cos of del V minus del I? Del V is minus 10 minus 50. So this is nothing but cos of minus 60 degree. Okay. So here Z value is minus 60. So V by I. So current is leading. Okay. So if it is minus means it is leading. Okay. So leading means the load is capacitive load. Like we have used capacitive load. So what is cos of minus 60? It is nothing but 0.5. Okay. So next we need to find the value of Z. I can find the value of Z, right? So Z is equal to 60 by root 2 into 1.5 root 2 and this value, right? Is nothing but minus 60 degree. So this is 4 into minus 60 degree. So I can write it as Z is, so you can expand this one, right? You can expand and write. So this in the polar form, you can write it in the rectangular form. So I have find out the power factor load impedance. Next I need to go for the P of t. P of t is equal to V of t into I of t, that is equal to 60 into 1.5 cos omega t minus 10 into cos omega t plus 50 degree. So this is equal to 60 into 1.5 and divide by 2 into cos of minus 10 minus 50 degree plus cos of 2 omega t minus 10 plus 50 degree. Okay. So 60 into 1.5 divided by 2 cos of minus 60 degree, right, plus 60 into 1.5 divided by 2 cos of 2 omega t plus 40 degree. Okay. So this is your instantaneous power, and we know that this is nothing but a real power, right? So real power is equal to 30 into 1.5. 30 into 1.5 is 45 cos of minus 60 degree. This is nothing but 22.5. Next, reactive power, right? Reactive power Q is equal to this one. What is this one? 45 into sine of minus 60 degree. That is equal to minus 38.97. So therefore the complex power is equal to 22.5 minus J 38.97. So here it is measured in terms of VAR. Okay, voltage amplifier, ampere reactive. Volt ampere reactive.